Hi everyone, I'm Manoj from the Venice team and we have Sushant here as well. Today, let us see how easy it is to try out Venice. As you all know, Venice is LinkedIn's distributed derived data platform, powering over 1800 datasets and over 300 distinct applications. Here, we're trying to containerize Venice and provide a quick start to create clusters and explore different aspects of Venice in a quick and efficient way. The ability to try out any software system is crucial for faster development, testing, and experimentation, especially for systems like Venice, which is a distributed system with many moving parts. The closest thing to a first class support for setting up clusters locally is the integration test framework via internal CI, which allows us to create throwaway Venice clusters in tests. This means that every time we need to do some experiments, we have to add new integration tests. There are many flows in Venice, including but not limited to the data ingestion and retrieval using different clients, partitioning, leader follower replication, active active replication among multiple data centers. If Venice clusters can be created easily, especially with multiple data center setups and a space to play around with it, it would be beneficial across the board to understand, use, and contribute to Venice, be it by existing or new contributors, partners, or early adopters of the open source Venice. We are leveraging Docker containers and Docker Compose tool here. Docker Container Image is a standalone executable package that includes everything needed to run an application. That lets to have each component of Venice as a Docker container running independently with its configured settings. Docker Compose tool ties it all together. You can define an entire application stack in a YAML file and spin everything up or down using a single command, which we'll see later in the demo. This diagram illustrates the components required to set up Venice cluster in a single data center. The sheer number of components and how they talk to each other makes it really difficult to set it up manually. If this is difficult, think about the setting up multi-data center setup with active-active replication. Multi-data center adds more complexity on top of the single data center flow with more components involved and introducing inter-data center communication. Let's quickly start the Docker Compose because it's going to take a few seconds for it to finish and let's get back to this. Owing to the limited time, let's just look at the Docker Compose file for the multi-data center scenario. Left side is the quick trimmed down version of the YAML file for easy readability, and right side is a part of the actual YAML file, which is more detailed. We can create multiple networks, each comprising multiple containers mimicking a different data center. But in this actual YAML file, we are using host names to differentiate between different networks. We are trying to create two data centers here. As you can see, DC1 and DC0, and all the components are up and running now. So if we give Docker PS, it'll basically show everything up and running. And that's it from my side. Sushant will take over now. Thanks.
Let us try out some of the features offered by Venice. To do that, we log into Venice client container. In this container, we have prepackaged sample dataset, store schema configuration files, and push job configuration files. To create a store in Venice, we need to specify parent controller URL, target cluster name, store name, and schema file locations. Let's create store. As you can see here, store was created successfully. Now we will add 100 records using batch push to this store, and each record is a key value pair. As you can see here, push job was completed in DC0 as well as DC1. Now let's run some queries. For key 90, we should get val 90 from both data centers. For key 100, we should get val 100 from both data centers. And for key 101, which does not exist in the dataset, we should get null. Now let's update data using incremental push. We'll update the values of last 10 records from the previous dataset, and we will also insert 10 new records. Incremental push was completed in both the data centers. Now let's rerun the queries. For key 90, value should not change. And for key 100, we should get updated value. And for key 101, we should get value inserted by incremental push job. Now let's tear down the cluster. It takes a couple of seconds to stop all the containers. That's it. Thank you all.